Okay, here we go. First review question. If I asked you where pi over 3 was, I'd hope you know that pretty easily, right? By now, I'm hoping that's like, oh yeah, it's about how many degrees about? It's about 60, so you'd say that that angle would go like right there-ish. Okay, I don't expect you to be perfect on that. But then you would have to drop down a perpendicular to the x-axis, and it makes a little, what kind of triangle? Reference triangle. And then this angle does not need to change. It is pi over 3, and it's okay. You don't need to change it. It's only if it moves somewhere else other than the first or fourth quadrant. So in other words, if you had to go over here, then you'd have to think up a new angle to go here for your reference angle. All right, so anyway, but what if I didn't give you pi over 3? What if I gave you 5 times pi over 3? Draw where that is and make its reference angle. You just multiply it, so it's 5 pi over 3. But then where is 5 pi over 3? One of the key moments is when you realize that 3 pi over 3 would have been right here. Because that's what pi is. 3 pi over 3. Cancel out and makes pi. So this, if this is 3 pi over 3, you got to get 2 more pi over 3s. That's a pi over 3, and then that's a pi over 3. So I'd say it ends right about there. Okay. And then did you draw a triangle like this blue triangle? And then did you label this guy as the reference angle? What would it be labeled with? It's not 5 pi over 3. Yes. Pi over 3. Very good. Yes. Yes, except on the inside of those triangles. Yes. I just want to reiterate that on the inside of these, I don't want to have negative angles. But you're right. I could have gone down 1 pi over 3 this way, and it would have got me the same result. But inside this reference triangle, everything's warm and sunny and never negative and never like really huge angles. So that's got to be a nice simple angle like pi over 3. All right, moving on. What's one of the ones you can't draw a reference triangle for? Like I say draw a reference triangle and you have to say I can't. Pi, good. If they say pi, you just go like this, you put a dot there, and you're done. Okay? And there's obviously 4 of those. That one, or this one, or this one, or that one. You cannot draw reference triangles for those. All right, next thing. If I asked you to find sine of 30, that should be easy by now. Make yourself a little helper triangle and figure it out. Hopefully you have it memorized, but if you make the helper triangle, it'll be easier to find the next question I have. So here's my helper triangle, 30, 60, 90. This is 1, 2, square root of 3. And so sine of 30 is opposite of hypotenuse. Opposite's 1, hypotenuse is 2, 1 over 2. Yay, that was easy. But of course they won't be that easy. So what would they be? We wouldn't use 30 degrees. We'd probably use radians. And we probably wouldn't use sine. We'd probably use something complicated like cosecant. So I'm going to ask you, use the same reference triangle, but figure out for me what the secant of, let me think of one that would work well here, pi over 6 is. First, hopefully you know what pi over 6 is. That should be an easy one. Change that to degrees to make your life a little easier, and then you know which triangle we're in. And then secant is something new we just learned a couple days ago, but I wouldn't use secant. I'd use the sister to it. So my first step is I make this secant of 30, but then I'd not even do secant. I don't know, I don't have them memorized. SOHCAHTOA is what I have memorized, and that doesn't have a secant in it. So I would instead use, instead of secant, I would use its sister, which is cosine of 30. But I got to remember to flip it at the end because it's not the same. So I'm going to put a 1 over cosine of 30 to remind myself to flip it at the end, because you can't just change secant to cosine. They're not the same. But I can change secant of 30 to 1 over cosine of 30. All right, now cosine of 30, cosine's adjacent over hypotenuse, that's root 3 over 2. So that's 1 over root 3 over 2. And then that reminds me to flip it because the answer is not root 3 over 2. It's 2 over root 3. Raise your hand if you got that before I did. Okay, good. Next. How about we do a simple one where I give you, the boy's making a ramp to jump his BMX bike. And this is 10 feet long. And he read in a book somewhere that he should be at a 20, no, let's make it a 30-degree angle because you guys are good at 30, 60, 90s, that the ramp should be at a 30-degree angle. He wants to know how long this side should be. I know the answer already. How about you? This doesn't have to take a long time. You got it? Anybody got it? Okay. If you don't have it fast, that's okay. Just change this to an X and go ahead and go through the whole process. But I think you'll see, you'll think about it more and go, oh, 30, 60, 90, I should have known. Who's got it now? Raise your hand if you got it now. All right. If you don't have it, here's what you should be thinking. All right, do I use sine, cosine, or tangent? Because I have an angle and I have a couple sides, I got to set up something. So I'm going to try sine and see if it makes sense. Sine of 30 is opposite over hypotenuse. Do I have the opposite? Yeah, I do. Do I have the hypotenuse? Yeah, I do. I can set it up that way. Yay. And then I happen to know that sine of 30 is a half. I have that memorized. But if I didn't, I'd make my little helper triangle and figure it out. It comes out to 1/2 equals x over 10. And now the x is almost alone. I just have to multiply both sides by 10, and I'll have it. 1/2 times 10 is 5. Raise your hand if you had 5. All right, good. Let's try a little bit harder one. Now, for some promotional purpose, he's told that he has to have the ramp be 3 root 3 tall. Still wants a 30-degree angle. How long does the ramp have to be then? Okay, sine. Yeah, I'm using sine again. Yay. Sine is opposite over hypotenuse, 3 root 3 over x. Things are a little harder this time, though, just because x is on the bottom. Sine of 30, I have that memorized. That's a half. If you don't have it memorized, you should. But you could always make a little helper triangle and figure it out. And then I got to get rid of the x in the denominator, so I'm going to multiply both sides by x. X here and an x here times by x. And then my x will cancel my x. And then I got x over 2 equals 3 root 3. And then I have to get rid of that root. There's that 2 on the bottom, multiply both sides by 2, x equals 6 root 3. Who had that one? Okay, good. That's the basics. That's not everything. Now, I skipped a lot of the easy stuff because I hope you already got it, like changed 150 degrees into radians or changed 3 pi into degrees or that kind of stuff. You just multiply by the fraction. I skipped a lot of the easy stuff, but now I'm going to give you a little quiz, and I'm going to pause the video for a few minutes while you try these few questions, and then after that I'll give you the answers, and then you'll have a bunch of work done on the review packet. So pausing for a moment. All right, so we're going to take a moment now and talk over how would you do these. Number 1 asks you to do 2 times 6 pi over 8. I'd go 6 and 8 can be reduced to 3/4. And then I go 3 times 2 is 6 pi over 4. And that can be reduced to 3 pi over 2. And that's a place. 3 pi over 2 is down here. And it's one of those places you can't draw a triangle for. How many of you caught that? Raise your hand if you were good on that. Okay, good. So you can't make a reference triangle or a reference angle. All right, on to number 2. Question on that? Okay, that was a hand. Number 2. Evaluate cosecant of pi over 3. I don't like cosecant, and I don't like pi over 3. So I'm going to change them. I'm not going to use pi over 3. I'm going to use what? 60. And I'm not going to figure it out for cosecant. I'm going to figure it out for sine. And once I find sine of 60, I got to remember it's not really what they asked. I got to flip it to get its sister function, cosecant. So it's 1 over sine of 60. Then I'm going to make myself a little helper triangle. This is 30, 60. Remember, across from the 30 is the 1. Across from the 60 is the root 3. The 2 is the hypotenuse. 1, 2, square root of 3. Now, sine of 60, here's 60. Sine is opposite over hypotenuse. No, wait, no. Yeah, opposite over hypotenuse. Am I doing that right? Root 3 over 2. What am I? I'm doing something wrong here. Is that right? All right. I just realized I might have done that wrong in my other class. That's a little scary. Okay, so sine of 60, sine is opposite over hypotenuse. That's root 3 over 2, so it's 1 over root 3 over 2, and that means you flip it, and it's 2 over root 3. Raise your hand if you had the same thing as I did. Okay, awesome. All right, on to number, which one was that one? 2? Okay, so on to number 3. Number 3 says, secant of theta is a half. I don't like secant, so I'm going to change it. You can't just change it without changing the problem, so I got to be careful. Instead of secant of theta, I'm going to do one I know, which is, that's the sister of it, which is what? Cosine. I'm going to do cosine of theta. But remember, if secant of theta is a half, cosine of theta is not a half, it's flipped. It's what? 2 over 1. Now here's the thing that's weird. I told you there was a tricky problem. This is one of them. If cosine of theta is 2, then I'm saying that cosine is adjacent over hypotenuse, right? How can the hypotenuse be smaller than the adjacent side? It can't be. You try to draw a picture for that, and you should have had problems. You should have been like, wait a minute. The adjacent is 2 and the hypotenuse is 1? You can't do that. So, undefined, or no solution. How many of you caught that? Ooh. You just all happily went along and said, okay, it's 2 and 1, and this must be square root of 3, and it can't be like that. It doesn't work. You have to have this side be the side that's the longest. The hypotenuse has to be the longest side. So that's an impossible triangle, and therefore, it's an impossible question. No solution. Correct. Question? You can't solve it because there is no answer. If you didn't have any answer at all, then it would be wrong. You don't worry about it because it's not going in the grade book. But just not answering the question is different than saying no solution. No solution is saying, I know that there is no answer to this question, versus just leaving the problem undone means I don't know what's going on. Okay, on to B, 3B. What is cotangent of pi over 3? Cotangent of pi over 3. What's pi over 3? 60. Crossing this off, putting 60. Cotangent of 60. Do you like cotangent? I don't. I'm going to switch it. Tangent. I'm going to do tangent of 60. But notice I'm not flipping 60. You can't. What the heck would 1 over 60 be? I don't know what that is. So don't try to flip the 60. It'd be the answer to it is going to get flipped. We don't know the answer yet. So anyway, instead of just replacing this, that's implying cotangent and tangent are the same thing. Don't do that. You've got to say 1 over tangent of 60 then. Now I can figure out tangent of 60. I go off to the side with my helper triangle, 30, 60, 90, 1, 2, square root of 3. And tangent of 60, tangent is opposite, TOA, opposite over adjacent, square root of 3 over 1. 1 over the square root of 3 over 1. And now I'm going to flip that, and it'll turn into 1 over the square root of 3. Who had that one right? Ooh, lots of people. Okay, backside. Backside hopefully was the relatively easy part. At least this part was. This is x, this is 8, and this is 30. You should be able to say, oh, I know that one. That's using the 30. I got to go sine, cosine, or tangent of 30. And which one is it? Well, I don't want the hypotenuse in it. There's only one that doesn't have the hypotenuse, and that's tangent. Tangent of 30 is TOA, opposite over adjacent. 8 over x. I happen to know tangent of 30 because I have a helper triangle for that. So I can go 30, 60, 90. Here's 1, 2, square root of 3. Tangent of 30. Tangent is opposite over adjacent. 1 over square root of 3 equals 8 over x. And now, this part, there's a lot of ways to get this x alone, but the fastest way is to cross multiply. That times that equals that times that. Anytime you have two fractions set equal to each other, not multiplied by each other, but set equal to each other, you can do this little deal, and it's really fast. X equals 8 root 3, and I'm done. And that's the right answer. Who had that one right? Ooh, again, good. That was probably the easiest question, so I'm happy to see lots of hands. And now number 5. Number 5 is a circle question, and you need to know this. S equals theta r. SOR, I like to say it. I like it's an SOR, okay? SOR formula. Problem is, if you just stick in the numbers as they gave them to you, which was, this is 40 degrees, and this is 12, I'd have S equals theta 40 degrees times 12, and what rule did I just break? Can't have degrees in that formula. That formula only works with radians. Okay, so I got to change my 40 degrees to radians first. So Trig's really picky. Each little thing's not that hard, but you got to be careful. So 40 degrees can be changed to radians by multiplying by pi over 180, and then you go cancel, 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 and it's 4 over 18 pi, and then I'm going to cancel that and make it 2 over 9, and I don't think I can cancel it anymore, so it's 2 pi over 9. S equals 2 pi over 9, that's my angle, times 12. So then I just multiply it out. 12 times 2 is 24 pi over 9, and if you had that, I'd cry a little and mark it wrong because you didn't reduce all the way. What goes into both of those? 3 does. So you go 3 goes in there 8 times, 3 goes in there 3 times, final answer. S equals 8 pi over 3. And you're like, wait a minute, that's this? That's a pi? Yeah, pi is just a 3.14. So it's about 9 or so. 8 times 3.14 divided by 3. It's about 9 long. And if it was in inches, it would be an inch. All right. So there's a quick little 5-question dealy, Bob. How many of you would have gotten a 5 out of 5? Nobody. All right. So that shows you that it's not going to be super easy tomorrow. But I will warn you, this little quiz was at least as hard as the test tomorrow. Okay, so this was a challenging quiz. So if you can handle this and feel comfortable with all of them now, then tomorrow's not going to be that scary. All right, your assignment is a worksheet that I'm about to hand you. I'm not giving you that much time to work on it, so I'm going to give you some problems that I would suggest you might want to skip, only because I'm only giving you guys 10 minutes to work. So that's all I have for the video for today.